Question number 79. An eye diagram gives an idea of options: modulation scheme, clock jitter, signal to noise ratio, all of the above. This question is quite simple if you know the concepts of eye diagram. But in major exams like GATE and IES, eye diagram concepts are never used and they have not asked in the exams till now. But exams like ISRO, this question was previously asked in the ISRO. I don't remember the year, but in ISRO it was asked 2 times. Okay, so same question, same options, it was asked in the ISRO previous years. Okay, you can just go through previous year papers, you will get the same question in 2 to 3 years. Okay, fine. Now before going to this, let us see what is this eye diagram. As I was already insisting you, we don't have any idea of what is an eye diagram. So let us go through what is eye diagram, how it is useful in the digital communication system. Fine. Now before going to, I have given some 4 points here. Before going to this 4 points, just I would like to explain you something, then we will go to this 4 points. Fine. So first we'll go to this figure, we'll understand what I want to tell you. See, you can refer any standard textbook, definitely you may not get this kind of useful information. You will get, but it is, you cannot understand the terminologies and the diagrams. See, all these diagrams I have collected from various sources. These diagrams you may not find in one textbook, so I have collected in such a way that you can easily understand. Fine. Now consider a 3-bit data, 3-bit message signal which you would like to transmit. Some 3-bit data you would like to transmit and same is received at the receiver. Okay, so what are the possible combinations? So 000, 001, 010, 011, 100, 101, 110, and finally 111. So these are the 8 possible combinations with 3-bit data. Okay, so everybody will tell this. So what is an eye diagram is, see, if somebody says represent 000, so how you will represent? So suppose these are the 3 times you have. Okay, so this is a graph you have. So how you will represent 000? You will represent something like 0, 0 and 0. Fine, everybody will do this, right? Now if I ask you to represent 001, so how you will represent? 0, 0, then finally you will represent a 1 like this. Okay, then if I ask finally one more question, I'll ask 110. If somebody asked you, then how you will represent? You will represent a 1, then 1, and finally 0. This is 110. So any logic levels you can represent with the help of a square pulse. But in general, the square pulse, exactly this peaks sharp transition from 1 to 0 may not exist. So in general, if somebody asks you to represent 110, then how it looks, I'll show you. See, I'm drawing a waveform for 110. 110 will look some, ideally it should be 1. Okay, 1, then 1, then it take a sharp transition, then make 0. 110 is the ideal one. But in practical, how it looks, I'll show you. This is 1. It takes some time, setup time. You might have studied in digital electronics. Then 1. Then finally it takes some time called hold time. Then it may not be sharp. What I mean to say is, in practical scenarios, these edges may not be sharp. They will be steep. Okay, they are gradual. Okay, they are not sudden. Okay, they are gradual. So that is the one point which I would like to insist before going to eye diagram. Fine. If you have understood this, then that's not a problem. Fine. Now let us see the next point. So what I have done is this two at a time I represented in the one figure. Okay, so y means I'll tell you. So 0000001 I represented in one figure in the form of gradual transition, not like a sharp edge. I'm not following this rule, I'm going for practical one, gradual rule. Okay, fine. So 0 0 0 I want to represent 0 0, then finally it should be 0. Okay, gradually 0 0 1, this is 0 0 1. Then first I should go for 0 0 0, sorry. So 0 0, it's 0, it is straight always. Fine, there is no changes here. 0 0 0. If somebody wants 0 0 1 0 0, then one should be, it should be a gradual increase. So I made 2 diagrams at a time I have taken. 0 0 1. Fine, these 2 are done. Now let us go for next 2. 0 1 0 means first it should be a 0, then it should be a 1, then it should be a 0. Gradually it should decrease. This is 1, this is 0, this is 0 0 1 0. If somebody wants 0 1 1, same, first 2 will not change. Okay, 0 1 and finally 1, only last bit I am changing. If you have observed, this is 0 1 1, because there is a change of 1 bit from this to this. There is change of 1 bit from this to this. Here also 1 bit change, 1 bit change. Then this also done. Let us go for third figure. 1 0 0 1 0 1. Let us plot 1, then find slowly I'll become 0, then 1 0 0, then 1 0 0. This is 1, this is 0, this is 0. If somebody wants 1 0 1, first two will not change. 1 0, then finally it will become 1. Then finally I'll go quickly, I think it's taking time. So finally what we have, 1 0 0 and 1 1 1. So 1 1 0, okay, this is 0 1 1 0, and finally 1 1 1. Fine, I have plotted all this 8 possible combinations in 4 different waveforms, 2 at a time. Two possible combinations I have taken into one waveform. So this 4 waveforms represent 8 different logic levels. Fine. So if I club all these 4 different waveforms, means indirectly I am clubbing all those 8 combinations. So if I club all those 8 combinations, what you get a diagram is known as an eye diagram. You can look at this. This is called an eye diagram. Okay, don't concentrate on the other figures when I am teaching, just concentrate what I am teaching. Okay, this is called an eye diagram. So what is this eye diagram, how it is useful, let us see. So you understood that eye diagram is nothing but it is obtained by mixing all the different possible combinations of a information. Okay, it's a 3-bit information, mixing all logic levels, possible logic levels from these 3 bits. If you mix, the obtained waveform is known as eye diagram. Fine. Now let us see the points. First one, let us see the definition of eye diagram. In digital communications, we have either a pulse of 1 or a pulse of 0 will have either 1 or 0. That's a binary information will transmit in digital communication. If you superimpose these 2 pulses on each other for several times, means all the possible combinations of those zeros and ones for 3-bit, you can go for 4-bit also. If you superimpose like that, you will get a pattern similar to our human eye, taking into consideration that a pulse 0 or 1, it should not be a sharp rectangle, because we are analyzing a practical situation, and it should have some rise time and it should have some fall time. This is called an eye diagram. You can go through once again. In digital communication, we have either a pulse of 1 or a pulse of 0. If you superimpose these 2 pulses on each other for several times, means you are superimposing all those possible combinations, you will get a pattern like an eye, taking into consideration that there should not be steep rectangular sharp edges and there should not be sharp falling down. Okay, means it should have some rise time and some fall time. This is known as an eye diagram. I hope you might have clearly understood what is an eye diagram. Okay, check the internet, definitely you will not get this clear definition. Fine. Now let us go for point number 2. First, we have seen how to construct an eye diagram. Now you may ask, like, sir, why we need all this? What is the purpose of it, this eye diagram? See, this eye diagram has certain uses, hence they have constructed. Let us learn those uses and then we will wind up this session. So what are its uses? The eye diagram, definitely it is used to detect the presence of noise. Okay, the main purpose is it is used to detect the noise in the signal. Fine. Before going to the uses of eye diagram, I would like to tell one point, that is, this is the complete area of the eye. Okay, this indicates the complete region of the eye where the eye resides. Okay, so in this region you can choose anywhere the sampling period. Okay, in this total area you can choose sampling period wherever you like. So the received signal can be sampled in this region. In this region you can at anywhere. See, some people will sample at this point, some people will sample at this point, some people here. So only in this region you can sample the received signal. So this is the region in which you can do the sampling of the received signal. Suppose if I do the sampling at this point, then you can see the height of the eye is little low. Okay, it is not the maximum height, right? So this is not the maximum. If I do sampling here, then you can see the height of the eye is maximum. Okay, so whenever you do the sampling and if you get the maximum height of the eye, if you get, then in that case you can easily conclude that it is a noise free transmission. Noise has not occurred, noise free. So if the height of the eye is maximum, only one point you remember, if the height of the eye is maximum, then you can say there is least amount of noise is present. So one point I would like to tell, the same point. So similarly the width also, if height and width, if they are maximum, then you can say, if both are maximum, both, then you can say noise is minimum. Noise is minimum. In this way you can conclude whether the received signal has least amount of noise or highest amount of noise based upon the height and width of the eye. So based on the width and height of the eye, you can conclude the noise is present, the noise which is present is maximum or minimum. So if the height of the eye is maximum, okay, you can say that the pulse amplitudes, means there are two pulses I already defined, pulse 0, there are two pulses, pulse 0 and pulse 1. See, these are the two pulses I have transmitted. Suppose there are two types of distortions possible. The pulse amplitude may distorted, pulse amplitude distortion, means the amplitude of the pulse gets distorted while it travels through the channel. So if the amplitude gets distorted, then it directly affects the height of the eye. Okay, if the height is low, then what does it indicate? You know, the amplitude of the pulses got distorted. I hope I'm repeating once again. If the height of the eye is low, then it indicates that the amplitude of the pulse has been distorted somewhere. Then one more way of noise, how to interrupt one other way of noise. If the width of the pulse 0 or pulse 1, see, consider once again pulse 0, you know what is pulse 0, pulse 1. So this is pulse 0, okay, this is pulse 1. So if pulse 0 and pulse 1, so these are the two input pulses which are transmitted by various combinations. If width of the pulse distorted, if width got distorted, then what happens? You know, it directly affects the width of the eye. By looking at the width of the eye, if it is low, if it is pretty low, see, for a good eye it will have larger width, for a bad eye it will have some width very low. Height can be normal, the width is, see, you can see the width is little low, here width is high. This is preferable, this is not preferable. If you get something this kind of a width, then you can say that the width of the original pulse 0 or 1 has been distorted. Okay, this is point number 1. Then already explained you height of the pulse. See, pulse 0 or pulse 1, if the height, I mean the amplitude, okay, it's not height, amplitude. What I am saying is, if the amplitude of the pulse got distorted, see, instead of exact 1, it is something distorted 1, okay, it is there is a distortion. Then if there is a distortion in the amplitude of the pulse, it directly affects the height of the eye. Okay, so means for a good eye it will have good height. For a distorted eye you will have a very low eye, it's like closing eye, it's like almost sleeping eye. Eye is almost, the width is very low. This is like not preferable, this is preferable because it has good width. Okay, it has good width, we can prefer this. Okay, so if you get this kind of eye, you can say that the pulse 0 or pulse 1 which the transmitter has transmitted is not distorted at the receiver. If you get this kind of eye, then you can simply conclude that either pulse 0 or pulse 1 amplitude has distorted. You can conclude this. So two things I am explaining you. If the height of the eye is low, then you can conclude that pulse 0 or pulse 1 amplitude has distorted. If the width of the eye is low, then you can conclude that the timing of the pulse 0 or pulse 1 has been distorted. So let us go through point number 2. So go through point number 2 slowly and carefully. See, it's very simple. If you have a noise on your pulse, this noise can change either change the pulse amplitude, which results in the closure of the eye. Means if there is any changes in the amplitude of the pulse, then it will directly affect the closure of the eye. Means the eye gets closed almost, means very low height as you push the upper sides of the eye. then if you have a noise that changes the timing of the pulse, if the noise is affected the timing of the pulse, then it can clearly seen in the width of the eye. You will have a jitter, that will call it as jitter. Okay, you will have a jitter that will close your eye from left to right side, means the width gets decreased if there is a jitter in the original pulse. If there is a some distortion in the amplitude of the pulse, then that will affect directly the closure of the eye. I hope this is clear. You can look at these two figures. If the width is shortened, then it indicates there is a pulse 0 or pulse 1 amplitude got distorted. Then if there is a that is for height. If there is a change in the timing of the pulse, then that is indicated by the width. This is for this it indicates amplitude of the pulse, that is indicated by height of the eye. For this, the width of the eye. Clearly remember the two things: amplitude of the pulse is indicated by height of the eye, and finally timing of the pulse is indicated by width of the eye. So these are the two observations we have seen. So by this you can say that noise of the received pulse can be detected with the help of an eye diagram. Then let us come to point number 3. In short, eye diagrams are used to check for ISI. So ISI is like some kind of a noise, intersymbol interference. It is also a kind of interference. Interference means noise. This we'll see in detail when we go for regular communication classes, when we see that. So just as of now you remember that this is a kind of a noise. So even ISI, even eye diagram can be useful to detect ISI means noise in the digital communication systems. So point number 4. Once again I am elaborating this ISI, what is it? So eye diagram will tell you how much ISI will be present at the receiver side. We just have to see in our eye diagram that at our sampling point, okay, sampling points can be many, but at our sampling point, how much is eye opening? Eye is how much it has been opened. If eye opening is wider, then you can say that received signal has less or no ISI. That's what I'm telling from long time. Otherwise it will have long ISI. So I was telling it will have many sampling points. Okay, at your sampling point, how much is the width, how much is the height, that you need to check. If the height and width are larger, then you can say that it is error free and doesn't have any noise, it doesn't have any ISI. If it is very low, it is almost like the eye is closing, then you can conclude that there is some error, some ISI, some noise is present, you can conclude. This is a simple brief explanation of eye diagram. Now I think you understood what is an eye diagram, from which the height of the eye, width of the eye, based on that you can understand how we can conclude noise is present or not. Fine, let us go to the third part. Okay, let us go to third part. Point number 3 or third diagram, you can see this is the complete area is called sampling area. So you can see this point, time interval over which the received signal can be sampled. It is a time interval over which you can sample the received signal at whatever interval, I mean wherever you like you can sample. Then this is the best sampling time. I already told the middle it is the best sampling because it has larger width and larger height. Then the intersection of this triangle, upper triangle with the straight line, that will call it as distortion at the sampling time. Then intersection of this lower triangle and upper triangle will call distortion of zero crossing. Then the middle height, the height from this top to middle origin is called margin over noise, and the slope of this indicates sensitivity to timing error. All these terms you may not understand at this point, but try to remember what is an eye diagram, what are its basic functionality and what are its basic uses, what its height indicates, what is its width indicates. That if you remember, that could be enough for this ISRO exam. Now let us go for point number 4 quickly because it's already late. So point number 4, you can see that for different modulation techniques, I would like to stress one point why I have included this figure is, for different modulation techniques the eye diagram will be little different, not completely different, it is little different. Okay, you can see for the first diagram indicates eye diagram for PSK. So by looking at the receiver, what you will have simply an eye diagram. By looking at that eye diagram, you can simply conclude which modulation scheme it is. So eye diagram, by looking into eye diagram you can conclude the type of modulation system. Okay, so for PSK you can say the eye diagram is in the figure A, 4A. Then for the same PSK, if there is some noise, interference, Okay, then the eye diagram which is present, first it was like this, then it will become like this, okay, due to noise. This is okay. Then you can see this figure, third figure. So it is the eye diagram of PAM, 4 level PAM. So you can see the PSK and PAM eye diagrams are completely different. So but always one thing is common, they have some eye in between. So here the eye is the middle portion, this is the eye. Here you have lots of eyes, okay, this and this, okay. So this indicates the eye diagram of PM. So what I would like to tell by point number 4 is, by looking into eye diagram you can say the type of modulation system, and also remember that for different modulation system there are different eye diagrams, but every eye diagram will have an eye. Fine, come to last point, okay. So finally I would like to conclude what is eye diagram, what are its uses. You have seen, just I tabulated in a table, okay. You can see eye diagram. What is eye diagram, what it will do from the eye diagram, what you can conclude. So come to point number 3. First I will discuss 3 and 4. Eye width, I already told, eye width indicates timing, synchronization and jitter effects you can notice with the help of the width of the eye. Then eye closure is same as eye height. Based on the height of the eye you can conclude how much noise has entered. If it is height is short, then you can say there is a lot of ISI. If it is larger, then you can say there is no ISI. So based on the height of the eye you can conclude intersymbol interference and additive noise. Based on the width of the eye you can conclude timing, synchronization and jitter effects. This point number 3 and 4 are very important. You may get a question, what you conclude from width of the eye, or you'll get a options, okay. Then point 1 and 2, let us see, they are also important, they're similar, okay. Eye opening, this is same as eye height. Point 1 and 4 for your kind information, they are same. You can see additive noise in the signal, it is same as additive noise, same. That's why I am not insisted. Point number 1 same as point 4, okay. Then point number 2, eye overshoot, the edges of the eye are undershoot. It indicates peak distortion due to interruption in the signal. What are the distortions present? It is indicated by eye overshoot, edges of the eye. It is indicated by eye overshoot. Try to remember these 4 points, 3 points. The eye diagram, what you can conclude. I hope you clearly understood what eye diagram, what is an eye diagram, what is indicates the user at the receiver. So at receiver, by seeing the eye diagram, even you can tell type of modulation system. Fine. You can go through these 4 points, you can go through the definition of eye diagram, and all these diagrams definitely it will help you to understand in detail. It hardly takes, second time revision hardly takes 5 minutes to revise, okay. So let us come back to our question, what is an eye diagram gives an idea of. Definitely by looking into eye diagram, I already told, it gives an idea of what kind of modulation scheme you are using. Then using an eye diagram, definitely you can conclude, it gives an idea of clock jitter, means the horizontal, the width part indicates the jitter part, okay. Height part indicates the ISI part, okay. In the table you can look over. Then definitely it indicates how much signal is present in the eye. By looking into eye diagram, definitely you can conclude if the height of the eye is very low, then you can say that there is a lot of noise and less amount of signal. So you can conclude signal to noise ratio also with the help of eye diagram. So the right choice is option D. Option D is the right choice. Just go through this video once again. If you have any queries, just post them in the comment box. I'll be going to reply all those comments, and also subscribe the channel for getting more updates. This is a very huge topic. I have cut shorted everything and have given, even though I have cut shorted, it took almost 20 minutes, but try to memorize everything and go through this video once again, okay. Thank you.